Hello and welcome. India just does not have enough vaccines to vaccinate the entire country or as many people that need to be vaccinated, particularly in the time frame that we want to do it. There are not enough vaccines to distribute within cities. There are not enough vaccines to distribute across the country, across age groups. This obviously creates the problem or compounds the problem of the Covid-19 disease spreading faster or coming back in new waves than we can prevent. That's one set of problems. The other set is, of course, the Indian variant, as it's now called, the B.1.617 or mutation of the SARS CoV2 virus, which is seen to be spreading not just in India very infectiously, but also in other parts of the world. So the two questions that arise is that what do we know or can we understand better about this mutation and how will it spread? And secondly, given where we are on vaccines, on the number of vaccines and the likely pace at which it will be rolled out or is being rolled out in the country, where do we stand and what do we need to do next? Just to put things in context, about 191 million doses of vaccines have been administered in India as of the 21st of May, but only 149 million are one dose and only 42 million are two doses. So only 42 million of a billion plus population have got both doses of the vaccine. And like I said, they're not enough. So to understand where we could go from here and what we can know more about the variant as well as the vaccine that will hopefully, or the vaccines that will hopefully respond to it, I'm pleased to be joined by Professor Polly Roy, Professor of Virology in the Department of Pathogen Molecular Biology in the Infectious and Tropical Diseases Faculty at the London School of Hygiene and Tropical Disease. Professor Roy received her PhD in molecular virology from the New York University, Columbia University Medical School, and continued to study RNA virology as a 3-year postdoc at the Waxman Institute, Rutgers University. For the last 3 decades, the predominant subject of Professor Roy's work, though not exclusively, has been the blue tongue virus or the BTV, a complex layered virus that is a member of the Revoviridae family. Now, Professor Roy's work has been recognized around the world, and she's received many awards, including the Office of the Order of the British Empire, the Fellowship of the Academy of Medical Sciences, the Indian Science Congress General President's Gold Medal awarded by the Prime Minister of India, and she was also a finalist of the Biotechnology and Biological Sciences Research Council Innovator of the Year Award. Professor Roy, thank you very much for joining me. So let me start with the mutation first. The B.1.617, as we're calling it, is obviously more infectious, or it appears to be more infectious than the mutations that we've known earlier. What do we know about this mutation at this point of time? And could this, where we are right now in the middle of May 2021, get worse? Or could it even potentially lose its efficacy or its impact as things stand?
Well, so far it appears, of course, some of these mutation, particularly this one, is a biggest drastic change. It is actually, I was talking about it the other day, that is a changes on the receptor binding site of the virus. And that change is drastic from one type of amino acid to the other, which makes it very a strong change, drastic change in order to binding to the receptor binding site AC2 of the cells. Now that changed a little bit, of course. This is also the site for neutralization. So any vaccines targeted on that will have to suffer a little bit. However, the vaccines are very robust when they make the neutralizing antibody. The large number of antibody was made, and they are made based on the whole, what we call the neutralizing antibody protein, the spike. Okay, so that's the reason it will still get some protection. If it's not complete, at least you will not get the disease. So if you have the first dose with that, even, we still get some protection against the disease, right, if it's not completely against the virus infection. But disease will cut down a lot because there are other sites of the spikes protein has the epitopes that also responsible for neutralization or protection. So this is very important to remember. So it's not so much disaster situation as we think.
Right, and I'm going to come to vaccines in a moment. So tell us more about this mutation in itself. Now, given your understanding of how viruses mutate, where are we? Is this Is this the most dangerous possible mutation? Could it get worse? And what is the usual journey for mutations like this in maybe specifically in the context of SARS?
So this one particularly looks like this particular position, which is called K484 position on the spike, on the RBD, the receptor binding site, is the one is always changing everywhere, wherever different country independently, nothing to do with India or other. But some of the changes are not so bad as Indian one. Indian one change is what we call from glutamic acid to, completely a different one, arginine. And I think that also they have leucine to arginine, as far as I remember. It's a drastic change that way. And so they accommodate a different way. They sit in a different way, this building block, when they bind to the virus. Virus bind to the receptor, and that may allow them, facilitate their entry better than the original virus. So that's the point. The virus vaccine that made was also because of original virus based. So they may not recognize completely. So that mutation is a key thing. But it is not so important when the change was less changing as a building block that has been shown in other countries. Only when it come in Indian, because they have spread very fast. So they will change a little bit silently, and then they will change drastic. This is the nature of the virus. They make the error continuously, making error because they're making copy of the genome, and they will make the error. The virus will make the error. And often those errors are not important, other sites, but certain sites that are very important. And this particular site, this particular position appears to be important. And that's also very exposed to change too much. So that's one of the reasons.
Right. And if you look at...
If you stop the infection, transmission is very quickly going on. That's why it changed. It would not have been that way if we controlled beforehand.
And if you look back over the last 1 year, how could the transmission have been different, or how could the journey of this have been different? And could, to that extent, have we been able to be I mean, could we have been better prepared for this mutation or virus, even if we had some foresight?
Absolutely. Because if you had two things, as you said before, also the isolation, distance from different people, gatherings, those things, because that allowed the transmission. Another problem with the SARS virus is very asymptomatic in many people. Not everybody can show the disease. When the virus first infect a certain person, you don't feel it even. And sometimes you don't feel anything. Another person can feel more. But the problem is after 3 days, when you know that you have some kind of problem, you don't feel good, this virus is already almost finished its job. So that is another problem. So if you're not separated from other group, you already have given to a whole lot of people without knowing. And that is the problem. And I think India, a lockdown first way was very good, but they started disappear. It did not. It is still there. Virus is there and going on. India has a very large number of young population there compared to other countries. And they are asymptomatic most of the times because virus is going slowly and few particles of the virus going, not large amount, not high doses, high load virus as we call. So older body cannot really accept the virus so much because they don't have any, less immunity, in general, innate immunity than the younger people. But when the virus load is low, younger or older, all will get infected. So that's what happened in India. Burst of the virus infection transmission, pressure on the virus itself, transmission. So they change quickly because they're making error, and some error are very good for them, not good for the host. That's what happened. It's good for them, and they can go quickly. But that doesn't mean, it doesn't mean they have taken over completely. No, because mutation is many other places, many other epitopes. There are T cells response as well. that doesn't change, So it is only one site, one point mutation happening.
Right.
So that's what probably the problem.
Right, and so currently we are seeming, at least in some cities, we are seeing the numbers ease off, and we're calling this the second wave. So now, what happens next? Because assuming the numbers ease off and keep easing off, though this is not happening this is not happening all over India. In many parts of rural India, for instance, the cases are still high, and more specifically, there is a problem of either no counting or undercounting. But assuming it starts easing off, what could happen next?
Well, I think that easing off in one place and not easing off the other place is always challenging, because people still going to travel, by train or by flights or whatever, car, whatever. And that is frightening for me, I find. So we have to be very cautious until we almost think that 70% people are already protected. At least only few people are around that it can really spread on the few people. But vaccine is the best. If you can give vaccine to that many people, then we're very good. Otherwise, we have to keep up avoiding what you call aerosol, because it's spread by all the time in aerosols. So that should be our mantra. I always say aerosol, aerosol, aerosol. You remember, is the air thing is you have to be, don't go to the dense populations, keep yourself safe by not going to the near
Right.
to somebody. If people think that, handshaking is bad, not necessarily so much. It's the distance very important. You have to be careful, because you don't know who is infected, who is not infected. Sometimes you don't know,
Right.
because they don't know. So
Right. Okay, so let me come to vaccines now. We have two vaccines in India, Covishield and Covaxin. The Sputnik 5 from Russia is going to start production at some point, but whichever way we look at it, it's going to take some time. Maybe we should have been vaccinating about 10 million people every day. Sometimes the numbers are closer to 1 million. There's a lot of vaccine hesitancy as well. The other problem is that some people have got their first dose of the Covishield. It doesn't look like they can get the second dose very quickly, and the government is trying to manage this by pushing the gap between the two doses. How do you look at this whole situation, particularly in terms of the vaccine efficacy?
I think all the vaccines that you have are highly efficacious, definitely. Less known about Covaxin that you have, because they have not done a lot of work on that yet. Not a lot of people got the vaccines. Covishield has been given to so many people, so it's very good. One dose is enough to stop the disease, if not the infection, in most people. And sometimes people say, oh, reinfected after vaccine, but they may reinfected just after a week or 2 days before. They don't know that when, because nobody knows when you get infection. It takes 2-3 days before you feel bad, So then you may say, oh, it's a vaccine. It is a vaccine effect. People are very happy to talk about side effect of vaccine, which is not a good thing to do, because you get side effect with the paracetamol as well. Some people get. So ibuprofen gives side effect to some people. So even the side effect you get some, everybody should think that I must take the vaccine if I am given. And as I said to you before, again, that vaccine should be available to everyone equally, and older people first, and then the way other countries are doing. And India
Right.
seems to be not every state doing the same way, but it's very important now. Not keeping locking all the old people in one room, and that's not a good idea. Either vaccinate, and they should be also have fresh air. That's another thing.
Right.
Fresh air is very important.
Right. So for those who've got their first dose of, let's say, Covishield, now earlier, and the data seems to be changing on this, the ideal gap was about 30 to 40 days. It became about 60 days. Now it's suggested that it's 90 days before the second dose. And that is a specific problem in India, because now, because of shortages, it's not clear whether people can get that second dose in time. So what happens then?
So even if you don't get second dose, you're not going to get tremendously badly sick that you have to go to hospital. If you get, because say even first dose should give you enough protection. Like
Till
you may
when?
get a little bit of fever if you get infected. You can get a little bit of fever and a little bit of uneasiness, but you are not going to be in deathbed if you don't have vaccine. So I would think that it's best that everybody at least gets one dose. If it's a less number of vaccines available, so everybody should try to get as many as possible first dose. And even the antibody that they generate on the first dose is evidence suggesting AstraZeneca's vaccine. At least you will have something until 6 months, looks like, from other countries. So you are protected still.
So you're
But you
saying
need a
6 months, right? So you're saying 6 months is how long it could take you, the first dose, without getting the second one?
will keep you, yes, looks like. Definitely. It looks like that you have some antibodies, circulating. It's a good idea to have a second dose if possible, but if it's not, it still is okay. It's not so bad, to have not to have a second dose. It is if you don't have vaccine, what do? You have to everybody to take the vaccine. So one dose is
Right.
good enough.
Right.
Yes.
But assuming you've taken both doses, how long does it keep you protected or safe
Well,
from what we know?
nobody knows about that, because what we test in neutralizing antibody in animals samples, this doesn't really equate to the actual cases, So antibody should last for a while, because the antibody level by the second dose it gives high level, so it should last for a number of. I would say definitely a year it should last at least, if it's not more, And it depends also a person to person, because some have already problem, people with a diabetic or high pressures or cardiac problem and lungs problem. They are the one you questionable, how much they can sustain the antibody. But healthy people generally it's not so much problem for any viral vaccine. Is very similar, should be. And spike is a whole spike vaccine that was both your Covishield. It had the whole spike. It's a good candidate for the whole. A lot of different epitopes are there. Also T cells. That's very good. It's sustained for much longer. And Covaxin is the whole virus vaccine. So they grow the virus and then they kill the genome chemically, and that's what they're using. So they have many other viral proteins those proteins help probably cellular immunity as well, if it's not neutralizing immunity. So far, Covaxin or inactivated vaccine for Chinese company been shown that at least 50% protection, they said. But because if the whole virus, so for example, the old type of vaccine that we made was live virus vaccine, what you call attenuated. It's a whole virus, but slowly you passage when you go to passage one, transmit one to another cell, slowly they go down and down in the severity of the virus. And those are the vaccine that made in the smallpox, for instance. But
Right.
this one,
Right.
COVID, is the same thing, the one that the Covaxin made in a way, but it's a killed. Killed means they change a lot already. And that's why it's less, but it's still robust in protection.
Right. Okay. So two questions again. So one is a lot of people have taken both the Covishield doses quickly, as in within 30 days in the first phase in India, particularly frontline workers and so on. So are they better off or not? Because the subsequent advice seems to be that you should spread it out and for better efficacy. So how does that work?
All vaccines generally is good in 21 days apart or 30 days apart, generally, priming and boosting. But for Covishield or AstraZeneca's vaccine has the adenovirus in it, little bit piece, even though it doesn't give a whole adenovirus, but small portion is there to take the spike protein inside the cells. And so this is called vector based. This vector will also generate some immunity, okay? And when the second times you come with the same vector, they may also, because neutralizing antibody will not allow to come too much, so that neutralizing antibody adenovirus may stop better response for the spike. So they're saying if you do further apart, it will be better off. So this is one reason they're doing that. Second reason is most important reason they're doing that, I think, is for all vaccine, because we don't have enough vaccines available for everybody. Right. And that's what we are doing, economized that way.
Right. But
so nothing wrong to take 30 days apart. Nothing wrong about that.
Nothing wrong. Okay, yeah. Okay. So, right. And the other question, which of course is increasingly cropping up in India, is that can I mix and match vaccines? Is that going to be dangerous for me? Particularly if I'm not getting the second dose of what I want.
No, it's better. It's better because we just have the result. I already thought when we talking about vaccine months ago, I said, oh, they should mix match, then better. The data just came out yesterday for AstraZeneca, followed by Pfizer in Spain, and 600 people all have much better booster dose and much higher than the same type if you take Pfizer, or AstraZeneca. So it is very good because there will be no interference from the first to the second. No interference of adenovirus anymore, adenovirus antibody. So it is good for doing that way. For mixed matching, it will be very good, as it has been done by Ebola virus successfully before. So I think, yeah, that's a very good idea. Whatever vaccine available, you can do. Because the vaccine is still really focusing on the spike of the virus, which binds to the receptor of the cells, and that will be neutralized completely, whatever vaccine you do. So it doesn't make any difference there.
Right. And you're actually saying that instead of thinking of it as a plan B, you should actually actively try and mix your vaccines.
Yes. I think that's what's going to go that way. I'm sure about that. Because most virologists knows about this. In people who work with viruses, and I made a lot of veterinarian virus vaccine. And I know that, I've done that myself. And it's easy to see, same like animals versus human, same thing. So I think that is the one way to go forward. And I think it'll be very good also for India to mix match the two vaccines they have currently. And
so you're saying you can mix Covishield and Covaxin?
Yes, of course. No problem there. Yeah.
Okay.
This is biologically no problem. Absolutely.
Right. Yeah. And I mean, we have the Sputnik 5, which is going to start production and get rolled out. We may have, we are trying to import other vaccines. Different states in India are trying to import. So you're saying as more vaccines come, just take whatever vaccine that you can get your hands on and you're fine.
Yes. Sputnik vaccine for in my knowledge, or my experience, I feel that is one of the best one probably, because they have already made their vaccine 2 doses in 2 different adenovirus. So they have no interference between 2 adenovirus. I mean, the vector itself has no interference to each other. So they design very nicely that. And they get, from beginning, they're getting 91%, 92% protection. In their clinical trial, they showed that. And I think that we should try to do that every country.
Right.
With different virus mix match to make sure that we get best protection, best neutralizing antibodies level.
Right. And Professor Roy, when you look at the data that you get from clinical trials, for instance, from all the vaccines that we've talked about are there across the world, are you satisfied with the quality of data, the insights that data gives you?
Yes, because these days they are very, very severe about all regulatory organizations, every country. They're very severe about that. We have to go through the phase 3 trials. Phase 1 and 2 are sometimes mixed, but phase 3 trials is very important. Which thousands of people have to be vaccinated. And that is very important because we mix match the age group, the different country people, if possible, to see genetically different. They think, in my view, all people will have a similar effect, more or less, but age group may differ. And AstraZeneca have done very well. So it's all different, and same about the Pfizer and Moderna. They all have done very well in that. Sputnik have done at the end. In the beginning, they did not before they announced, but they have done also very good trials on the phase 3. Covaxin, I don't know yet on the phase 3 trials, whether they have done well or not. How many they have done, I did not see the report yet. So maybe they didn't have the chance yet to do it.
Right. Professor, one of the concerns that's emerging now, again in India and maybe other parts of the world, is children. And one is, of course, should children get vaccinated, and your understanding of it. And secondly, if they do, then what is that something that we should be concerned about, or what does your experience tell you?
No, I think the children are not so susceptible very much of for this disease anyway. For maybe infection, but not the disease so much. So people have to consider first the adult, and then if you have opportunity, children should take it. Nothing wrong will happen. Nothing bad will happen to them. At least they will not. They are not very good spreader either. The children, young, yes, they spread, but not the children. They don't spread because the virus doesn't multiply very much in their body. But even if all the children have taken as well as adults, then we have no problem of this virus will disappear from everywhere globally. That's what we want. Globally, it had to disappear. We cannot just say that we protected this country, that country, or that regions. Doesn't mean. And that for you, I know that Delhi is very good right now. They're saying not enough disease, but other places you have a lot still going on. In the outskirts of Delhi, they have a lot.
Yeah.
So that doesn't help you because somebody will bring it back again if you're not vaccinated. But if you're already infected, of course, you're not going to catch the virus again that easily. No. Unless virus changes.
And you're saying there is, there's nothing medically wrong, or at least from your point of view, with a child getting vaccinated. And when I say child, or when you think of children, are you thinking around 10 years old or younger, or?
That's what we are thinking. Yeah, 10 years old or younger even. But I think that we don't have to worry about them so much yet. Because vaccine is still not so abundant that everybody can take it. So we have to wait. Don't push so fast for them. But yes, eventually they should make it also.
No, and the reason, Professor Roy, and the reason people ask is obviously because schools have now been shut for more than a year, and parents are anxious whether children can go back to school, should go back to school. If so, should they be vaccinated? I'm sure this is a global question.
Yeah, I know, here too. But here, everybody going back to school. And they will get eventually vaccine also. As I said, they're not a very good spreader of the virus. They can pick up the virus, but they may bring it to home to the adult, So adults have to be vaccinated first, I think. But children can be vaccinated and they can go back to school, definitely. But there are teachers that they have to be vaccinated first before children can go back to school. Children around 13 onwards, America already started vaccination, from 13 onwards. So younger one, they will probably wait for a while until we have a lot of vaccines. It doesn't do any wrong because it's not the old type of vaccine. It is just a genetically engineered small piece of virus only there. It should not do any wrong to anybody, really. And when the people say side effect, which is, I think a lot of them are just stories as well, not necessarily absolutely directly relevant to the vaccine.
Right.
Don't believe that.
Right. So, to come back to the current mutation and potentially future mutations, how would vaccines, would vaccines also need to keep getting re-engineered, and will they get re-engineered quick enough in your understanding? And would it also mean, since you mentioned it earlier, that every year I may go for a new shot, which may be different from the previous shot because it would be re-engineered to accommodate newer variants? Or how does that work?
Well, both for adenovirus-based vaccine and the RNA-based Pfizer vaccine, Moderna, very easy, particularly Pfizer and Moderna, very easy to make the new variant, very quick. It's synthetic because it's very easy to construct it and do it. Same about adeno-based. It's not difficult anymore because we can change it very easily. All the genetic engineer, we change here or there mutation, we are making all the time. That's not a problem. I mean, I do research with the COVID, some part for vaccine purpose, but we change on the mutation to see how good for this, what is not as a vaccine purpose, but as a understanding of the virology part and how protein interact with each other and how they make it. That sort of thing that I work on. And one can do it very fast, no problem. The major problem is the manufacturing. They have to be upfront all the time doing this, So that's what I suggest that almost every country in India should have many manufacturing places. Not one is one place that everything goes there. If something happened to that, something goes wrong and that's it. That's not good. Every country should have manufacturing facilities, and this is not that difficult to build up, That's the one way we should do it. But after a few years, maybe we'll never see it again, SARS. Maybe we'll disappear completely. So we have to be just proactive. I still think the best thing that we're a little bit careful about mingling, who I'm mingling, socializing. Because I don't know the person. If you know somebody, you go. But we call it our bubble. But if you don't know somebody, and how do you know the person not carrying the virus? Because as I said, many people, like husband got the virus, wife did not, got the virus, no symptom. I tested them myself. That's why I know in my neighbor, So the problem is that they both have antibodies, but one never had any symptom, other had severe symptoms, same age group, different immune system. That's the problem each one has. So it is not straightforward that way. However, we have to be a little bit cautious for a year at least, not to go to big gatherings so easily.
Right. Right.
So just be cautious. That's it.
Right. So, Professor, last question. So, as you look ahead and as you look back as well, particularly in India or elsewhere in the world, what are the 2 or 3 key lessons that you feel everyone? I guess maybe the lessons are the same, but those who make policy as well as those of us, the citizens trying to go about our daily lives or get back to our daily lives, should be aware of or should be focusing on.
Transparency. We have to be transparent. Everybody has to be honest and transparent what they're talking. No point to hide something. If you have a problem, you share with the world. Because that's the only way one can help each other. It's a global problem. It's hiding that and telling wrong data is not a good idea at all. Everybody have to be transparent and let the really immunologist and virologist, if it's a viral disease, to be included, making the decision. Not politician, not only epidemiologist, the virologist and immunologist know how the virus works, how the immune system works. This one lesson we have to learn properly from beginning and share the data. For India, you still don't have enough data of sequence to tell what's happening. And not from one area, for every area, you have to see that how spread this particular mutant. We don't know. You don't have to have everybody, but you have to have some representation from every places to see which is going on. And India can do it. India is very well known for their good science. And why not? They should do it, all of these things. Give the priority to do this and vaccine making quickly. Not depend on other countries' vaccine. You can make it all simple one. Instead of making even co-vaccine, you can make the way we are doing here, with the spike protein alone, engineering, which is very fast to do it. You have to understand co-vaccine it is making actually highly infectious virus. You have to make large scale. and then you inactivate. If you are not
Right.
cautious, what happens if one person have some problem with that? That's it. You may spread the virus. So we don't know that. So yes, we can make it. India can make all this vaccine very easily. I think they are now not doing this patent right so much.
Right.
And before it didn't make it, so it's very easy to make it. Actually, this vaccine.
Right. And your last bit of advice for the common person.
Be very vigilant. Not just go jumping in everything that you see, all these processions and all these religious gathering, which I'm very, very against. All these big gatherings. It's just, I find that is ridiculous in today's day situation. One should not think about going anywhere like that anymore. Because when you lose your very favorite, your loved one, how difficult it becomes then to accept that you brought the virus in the home, at home, yourself maybe. So you don't know that. So better better to be cautious all the time for a little while. I think India have to do for 6 more months, bit more cautious, and then we'll see how it happens. We don't have to be cautious anymore. Almost looks like in the UK they're saying, but I'm still cautious. Doesn't mean that I'm rushing to a cinema or restaurants immediately because I'm absolutely starving. I don't believe in that. I mean, you have to be cautious. You just don't have to do that certain things. You have to change your lifestyle a little bit. Lifestyle changing is a good idea sometimes, time to time. You have to go with the flow, I said. Whatever is necessary.
Right. Professor Polly Roy from joining me from London. Thank you so much for speaking to me and us, and do hope to speak to you again and pick your brains, as it were. Thank you very much.
Thank you. I enjoyed it. Thank you. Bye.
Thank you.